Alright, let's take a look at another problem. Still in section 3.5 here. And this is one where they've kind of come up with a formula for us already. It says, to estimate the age of dead organic material, scientists use the following formula. R equals 1 over 10 to the 12th power times E raised, and this entire thing up here, negative T over 8223, is our exponent. They want us to estimate the age of a newly found fossil in which the ratio of carbon-14 to carbon-12 is this formula right here. So this one's pretty straightforward as far as it's a substitution problem. So if we know what R is here, we're going to set this one equal to the R value up top here. So we're going to get R. Oops, let's go back. I don't need R a second time there. R is 1 over 10 to the 13th, and that's going to be equal to what we've got on the right side here, 1 over 10 to the 12th, E, all raised to the negative T over 8223. So on this one, like always, we're going to try and isolate the value that has the exponent in it. In that case, that value is E. So we're going to multiply both sides by 10 to the 12th. So that's going to cancel out on this side, and 10 to the 12th over 10 to the 13th just gives us 1 over 10, or 1 over 10 to the 1st. So now we've got this. And now we're right back where we've been on quite a few problems already, where we're just going to apply a natural log so we can pull down this exponent. So we're going to do a natural log of 1/10 equals a natural log of E raised to our exponent here, negative T over 8233. Oops, my 33 evolved. It should still be 23. So on this side, we're not going to change anything. We get natural log of 1/10. On this side, again, we have a base E and an E, so our exponent can come down for simplification. So we get negative T all over 8223. And then we're just going to multiply negative 8223 on both sides. And that's going to get us our value for T. So on this one, once we simplify this, T actually becomes approximately 18,934. And again, that would be to the nearest year. So pretty slick. Substitute one ratio, set it equal to another established ratio, and we work our way through, and we can find pretty exact how old that newly found fossil would be. Alright, we're going to take a look at something different here, maybe a little bit with an explanation more so than actually doing any solutions on this one. And this would be the case for our Gaussian model. And the model that we're going to look at, or the problem that we're going to look at here, is going to be along the lines of SAT scores. And one big thing with the Gaussian model that we talked about way back at the start of this chapter was it's used a lot in statistics and a lot in probability, and on this particular problem, what they're talking about is for a standard normal distribution. So let's put that in words here. Standard normal distribution. And obviously, a lot of you haven't really had a whole lot in statistics right now if you're in this class. It's possible you've seen some of this, but you actually end up with an equation that looks like this. Y equals 1 over, and then we've 2 pi under a square root as our denominator, all times e raised to the negative x squared over 2. So again, this entire thing up here is our exponent. Alright, so one of the situations that they've got here was they were telling us that in 2008 SAT math scores for college-bound seniors, and they plugged in a few values and they simplified this all out, and they actually ended up with an equation that looked something like this. I equals 0.00, my 0 doesn't want to write here, 0.0034 e, and that got raised to negative x minus 575, oops, 515, sorry. I'm in trouble reading my own writing here. That's all squared. And then that's divided by 26,912. Alright, so they did a little simplification already for the numbers that they were given. They did the work. They came up with this equation, and they also set a boundary for our x value up here. Has to be between 200 and 800. And again, those are going to be our scores for our SAT math. And again, this was college-bound seniors in the year 2008. So they plugged all this in. The x was the actual SAT math score that they got. Once they simplified everything, they went to graph this. They got a graph that took on our normal distribution like this, or fairly normal. We only looked at x values from 200 to 800, and we're not going to take the time to do this one right now, but we could go through and simplify a couple different ways, and it actually turned out when they did this that the mean of this normal curve was right around 515. So again, found by the calculator some graphing situations. Basically, they were telling you the average score based on this model would be about a 515 on the math score.